Hello everyone, this is our team ElectScoot and today we are going to present this Satkam topic on electric scooters case study. So we consist of 4 members, that is Varad Vaidya, myself, then Junaid Ali Sheikh, Ayush Manoj and Harjay Singh Pure from B3 from REIIT Pune. So these are the questions we have been looking onto. The very first thing is the company wants to do an analysis of the app and what it needs to improve it. Mind map the 10 features you would want in the app for the electric scooter and explain which are the top 5 features which would be most useful and why. So 10 features that we think that electric scooter should have, that is first is live battery, status of esteemed range. Second is predictive low battery alerts. Third is Google Map integration in the electric scooter for the routes. Fourth will be remote unlock and lock option for the electric scooter. Fifth is OTA, over the air updates. And the sixth is document upload and storage for in the electric scooter regarding all the previous data. Next is ride analysis of speed, distance, eco score, and all the past data of the electric scooter. Next is maintenance reminder, auto maintenance reminder using the ML models. Next is service center locator and appointment booking for the scooter. And the last is smart AI based ride suggestion. These are the 10 features which are there in the electric scooter. But top 5 which we feel most useful are the very first, that is live battery status with predictive low alerts. As we see that whenever we ride the scooter, the battery health gets discharged and the user faces a lot. So this should be there to prevent the losses of the user of in terms of time, as well as the efficient use of the electric scooter should be there. The second is Google Map integration, which is one of the major features now with the development in the society and the roads. We need that the Google Map integrations or any other maps Google integration should be there, so that the user can be able to visit or roam to his esteemed destination without asking to anyone regarding the roads, neither getting lost on the regarding the roads. The third is remote lock and unlock. The remote lock and unlock system is very efficient in terms of safety. As we see in the user, the getting thieves are there, and there are very high chances that our electric scooter might go anywhere. So a remote lock and unlock system should be there, which should be replaceable to the keys. Then the fourth is document storage, centralized on and off on vehicle access. So whenever the police or the any RTO officer connects with us, we are supposed to show them the documents, and those documents should be easily available to us in the e-form or in also in the e-vehicle, electric vehicles, so that they can check the access of the vehicle. All the related documents of the vehicle, and it won't be trouble for us that we have lost the vehicle charges, vehicle papers or and all. And the last is maintenance reminder. We all need our vehicles to be maintained after a precise time, because once if we stop working on the maintenance of a vehicle, we feel our vehicle may get damaged after a quite period of time, and the most efficient use of the resources of a vehicle cannot be done. So maintenance of vehicles should be proactive over the reactive. Before any actions come or any safety issues come, we should uh, do the maintenance of a vehicle, and that is why maintenance reminder should be there in our project. And the second question we have looked into is, there are some of the design consideration you would have for designing the storage feature, and what all will you need to consider for security of the documents while designing the architecture. So what design should be there and what architecture should be there. So design consideration should be easy document upload through the app of the from the to the vehicle, sync documents securely with the vehicle dashboard, so that we can check the documents, uh, are which documents are connected and which documents are updated for the a particular vehicle. Simple document retrieval while riding, minimal distraction and all. And the fourth is support multiple formats like JPG, PDF, PNG. All these formats should be supported. So security measures for the same are use AES 256 encryption for stored documents so that our data won't be leaked. Second will be secure HTTPS connection for data transfer. The third is two-factor verification. Obviously, two-factor verification should be there in terms of OTP via mail or contacts or any other, or we can also use fingerprints. The next is access control to allow only verified user. only verified users should be able to control the access. And the last is use Google Cloud with compliance to ISO 27001 or equivalent. We should follow the standards for the vehicle and work up to the security and design for the documents. So next two questions will be answered by the Junaid Ali. So over to you, Junaid.
Okay, I'm audible. Okay. Next questions we are looking is list the potential reasons for any two of the issues which the customers have complained about and write the test scenarios you would use to test and ensure they have been fixed. So first issue is being charge running out without warning. So this is an potential issue. So for that, what are the some reasons? For that, in the first is poor battery health estimation algorithm, which is working in our scooty. Then second is app not syncing with scooter in real time. And the test scenarios for that is similar battery uses till 10%, 5%, and 2%. Check warning systems, which will give by the scooter. And the test real-time syncing of battery percentage between app and vehicle. Then second issue is UI of app is clumsy. For that, what are some potential reasons? In first one is non-initiative layout, cluttered UI, poor color contrast. And the test scenarios are conduct usability testings with 10 to 15 target users so that it will be easy to uh, understand the UI. Then second is use heat maps to analyze click behavior. And third is perform A/B testings with new UI prototypes. Then the fourth question is use the inside and outside in the techniques of releasing the product in the market and list top five things you would do in inside out planning to release the new app to the market and outside in planning for releasing the new app. So first we will discuss inside out planning, which is company first focused, in which first is define apps architecture with performance and scalability. Then second is redesigning UI UX with design sprint. Then third one is collaborate with the hardware team for seamless syncing. Fourth one is conduct internal testing and simulations. And last one is plan phased rollouts with internal employees as first user. And the second thing is outside in planning, which is customer first focused. In that, first one is interview target customers for pain points. Second is run beta testings with real users. Analyze app store reviews for competitors. Build community feedbacks, lookups for app. And the last one is market launch plan with clear messaging on new improvements. And the next two questions will cover by Ayushman.
Thank you, Junaid. Please change. Huh. So basically, in this slide, we are going to be discussing about the features which are MVP, that are used in minimal viable products or not. So this question covers the top 10 features of selected the top 10 features which you have selected to do a relative priority exercise. Mark them for P1 and P2 and then from 1 to 10 explain what you have decided on those priorities. So P1 features are basically directly related to safety, usability and ride reliability, which is a customer experience. And P2 features are supportive and experience enhancing, but are not strictly considered for MVPs. So first feature is life battery status with estimated range. It is an user safety and usability features, which is crucial for everyday users, so they can know how far they can drive their vehicles at what battery percentage. Next is predictive low battery alerts, which helps user in getting a prediction about their battery health of the scooter and accordingly maintain the scooter health. Third is Google Map integration with real-time navigation. Fourth is remote unlock and lock, which is a basically safety feature for the users. And the fifth one in the user reliability and usability feature is maintenance reminders, which helps to maintain the scooter for long-term usage. Now, next covering about supportive and experience enhancing features. First one is document upload and storage, which Bharat has discussed in a very better way. Second is over the air updates. This keeps updates of the software and but are not needed frequently, but still it is mentioned here because software updates are necessary, and according to the version everything will be used to update and enhance the networking. Next one is ride analytics, which is basically useful for tracking performance. Next one is a service center locator and appointment booking, which is convenient for users to help during breakdowns. And the next part is smart AI based ride suggestions, which will help user to have better experience while their travel journey. Next one. The company is collecting the data in the cloud already, but have performance issues to update. Collect the data and update the app, which can be the reasons for that and what could be need to be improved for data integration from vehicle to cloud and to send the data post analysis to the app. So possible issues for these are poor API response, inefficient data modeling or high latency queries, improper cache management, and overloaded backend services. So, to overcome these issues, the improvements which are to be needed to done are usage of edge computing for real-time data syncs, optimize API with pagination, compression, and reduced payload, implement message queues like Kafka for smoother data streaming, add caching layers for repetitive requests, use auto-scaling cloud infrastructure. In this way, the issues can be resolved. Now, next questions will be discussed by Harsh Jaisinghpure.
So, hello everyone. Good evening. I'm Harsh. So, I'll be discussing the last two questions from this fun activity. The questions are: the company would like the app to have intelligence and provide recommendations to the driver. What kind of data should the app collect from the vehicle, and what kind of recommendations can be done? Is there a possibility to use ML and or AI for this analysis? And if so, what can be the use cases? So the solution for this goes like: data to collect. Firstly, rider speed, route, turn time. Secondly, battery charge cycles and health. And third is users' travel patterns, that are timing, locations, and frequency. So recommendation examples goes like: first is suggest eco-friendly routes. Second is recommend battery-saving modes. Third is alert for next service based on driving habits. Fourth is suggest best charging time slots or nearest stations. So AIML best use cases can be: first is predictive battery life modeling. Second is smart maintenance prediction. Third is personal ride insights using clustering. And fourth is fault detection using anomaly detection in sensor data. Where we can go for next question. Yeah. So the last question from the slide is: use the product solutioning concepts and create a mind map for the new version of the vehicle, explaining the goals, features, UX changes, and UI changes, if any, you want to target in the scope. So the solution for this goes like: first is the goals, become second in market in 1 year. Second is zero key issues in 6 months. Third is 50% sale increase. Fourth is 10% of profit per vehicle should be done. Now we can discuss the features like: it should be fast charging, that is less than 4 hours. It should be lightweight redesigning so the vehicles could move faster and use less battery. Third is its dashboard should be touch screen. Fourth is